Good afternoon, one and all. I am Lambe SM. Uh, uh, I am a research scholar in electronics engineering under the guidance of Professor KJ Karande. He is a principal and director of SKNCV Pandarpur. My research, one of the objective of PhD research topic is a long-term effect of power factor correction capacitors on the academic institute. Actually, my topic is related to protecting power factor correction capacitors from harmonics. Within that, there is a one objective that is a protect a long-term effect of power factor correction capacitors on the academic institute. And these are my contents of my presentation. Need of installation, introduction, proposed methodology, result and discussion, and finally the conclusion. Now, power factor is a cause of angle between the applied voltage and current flowing through the load. If the load is purely resistive, then there is no cause of the angle between applied voltage and flowing current is zero. So the angle is zero, so the power factor becomes cos zero equal to 1. And if there is an inductive load, then that cos angle becomes lagging cos angle. And if there is load is leading, that is capacitive load, then the angle becomes leading. So actually power factor is the how much applied power is converted into actual utilization. It is indications of that. If power factor is unity, it indicates that totally power is utilized. There is no wastage of power. And if there is a some value of power factor, it indicates that that much power is utilized and other power is wasted. For example, if you consider a power factor is of 0.8, it indicates that 80% power is utilized and 20% power is wasted. In industrial load, actually there is always a high rated motors, and motors contains the inductive load, and so that the power factor becomes lagging. So to avoid this wastage of power, a compensating reactive load is connected. And how the economic benefits get the industry, that explains the my presentation. And these are the points. So why we need to install the power factor improvement increases energy efficiency, it reduces power losses, voltage applied becomes stable, it increases system capacity, it increases the utility cost saving, compliance with regulations. That means if we industrial customers consumers if do not install the power factor correction bank, then they are fined by the distribution network. So customers need to install the power factor correction capacitor bank. And as our power factor correction capacitor bank installed, it increases the equipment life, and finally it has a lot more environmental good impact also. So every industrial load is of inductive type, and they are having the higher ratings. Average power factor of industrial motors is 0.7 to 0.8. It is a lagging because motors are having the inductive load, and inductive load provides the lagging power factor. And the power factor changes with respect to torque. If you consider a transformer of 100 kVA and it is having 95% efficiency, so that means it delivers 70 kilowatt is the active power, and wastage power is of the 25 kVAR. If the power is in wastage form, then it is measured in kVAR, and it is utilized, then it is measured in kilowatts. So that much power is wasted. So to prove the benefits of power factor installation, I purchased a three-phase 1 to 1 ratio isolation transformer from market. I utilized a 1 HP motor, and for that I utilized a reactive power factor load of 0.5 kVAR. And from uh, this is the block diagram of system installed. here, uh, here a load of 1 HP motor is used. Two MCBs are used to provide direct supply to motor, or another MCB is used to provide supply to the motor through the VFD drives. And there are another MCBs where I connected phase to neutral, phase to neutral 10 MFD capacitors to improve the power factor. And according to that, the calculations are proceeded further. Here are two diagrams indicating. Left diagram is phase to neutral voltage is of 241 volt, having the current of 0.30 ampere and power factor of 0.93. Actually, load is running in dry condition, so it is having the 0.93 power factor. If load is under load, then the power factor fully downs up to 0.7 also. And in another diagram, if I connect the 10 MFD phase to neutral reactive load, it indicates the current is reduced to 0.30 to 0.28, and power factor is improved from 0.93 to 0.97. It means that as we connect the reactive load, the current demand decreases. Current demand is decreased. It is indicated here. Actually, my research center is SKNS COE Pandarpur. There they have a 100 kVA transformer, and they have a automatic power factor correction bank of 30 kVAR. And left figure indicates the 30 kVAR APFC unit, which standby units are there. If one unit gets failed, then automatic another units comes in action. So there are standby units. And in another diagram, it shows that APFC unit maintaining a power factor nearly to 1. It is maintaining 0.99 means nearly about unity. So wastage of power reduced to almost zero. So it indicates the splitted capacitor bank 10 kVAR, 10 kVAR, and another 10 kVAR. Total connects the 30 kVAR. So it was my one of the objective from my PhD research topic, and as all that results I collected, the team from Maharashtra State Electricity Distribution Company Limited engineers were come to visit my experimentation work, and they appreciated my work also. It is indicated in another figure. Actually, the calculation how much the reactive load should be attached, that indicated here. So the kVAR final main formula is kVAR to be added equal to power into tan of phi 1 minus tan of phi 2. Phi 1 and phi 2 are the uh, uh, that are the cos angles between voltage and currents. So for 1 HP motor, the load reactive load to be connected is of 0.30 kVAR, and if you convert that 0.30 kVAR into MFD, it becomes 10 MFD phase to neutral reactive load. And I proceed, put here further result. If you go in two ways without reactive load, how much is the expenditure? If you consider three-phase motor, 1 kVAR transformer, load of 1 HP and power factor of 0.8, then power loss per hour becomes 0.15 kWh. Power loss per day becomes, if a motor runs for 8 hours per day, it becomes 1.2 kWh. Power loss per month becomes 36 units. Power loss per year becomes 432 units. As a commercial rate, if we consider, these rates are 10 rupees per unit, then the economic loss per year becomes 4320 rupees if we do not use the reactive load. And if we use the reactive load of 0.5 kVAR, it is having only the cost of 400. So it is better to use always a reactive load instead of running a inductive load without reactive load. So these are the comparative study. It indicates that if I use the reactive load, it gives me cost of 400. And if I do not use the reactive load, it wastes a amount of 4320. Actually, energy creation in beyond that energy creation, actually distribution should be very clear, and there should be common policy from distribution network. If anybody doesn't install the reactive load, then they have to fine. And this is my suggestion. And so it is always beneficial to use reactive load. And actually, I have proud that my research center are having APFC unit since last 10 years also. So it is a need of time to use the reactive load to improve the power factor. That's all. Thank you.
Okay, thank you, sir, for your presentation.
Thank you, ma'am.